Hello guys, in this question you can see that this is a arc of wire which is carrying some current I in this direction, and the radius of this arc is variable and it is changing with theta, like that, where B and C are some constants, and angle theta is measured with the positive x-axis in anti-clockwise sense. Now we have to calculate the magnetic field due to this arc at the origin. Now this is a level 3 problem, and in this you can easily see that there would be a element of wire dl, and this is tangential and this is radial, so the angle between dl and r will be 90 degree, and dB, due to this small element, dl will be equal to r d theta, okay, and dB will be mu naught I dl sine theta by r square into 4 pi. This is the general formula of Biot-Savart law. So dB will be mu naught I dl is r d theta sine theta divided by 4 pi r square. Cancelling this r with r, dB will be equal to mu naught I by 4 pi r, and this is sine theta. Sine theta, theta will be the angle between dl and r, and this is 90, so let us substitute the value of theta as 90, and sine 90 is 1 obviously, so this will be this. Now dB will be mu naught I d theta divided by 4 pi b plus c theta by pi, and b will be equal to mu naught I by 4 pi ln b plus c theta by pi, and the limit of this theta will be from 0 to pi by 2. So b will be equal to mu naught I by 4 pi ln, if we substitute the value of pi by 2 here in the place of theta, then it would be c by 2, so it would be b plus c by 2, and minus ln b. So the final answer will be, let us write it down on the next page. So b will be equal to mu naught I divided by 4 pi, and ln a minus ln b is ln a by b, so it would be 1 plus c by 2b, ln 1 plus c by 2b. This will be the magnetic field due to this arc at point O. Now let us move on the next question. In this question you can see that this is a current carrying wire in a shape of a semicircle. The radius of this wire is r and it is carrying a current I. M is the midpoint of this arc and P is on the axis of this arc. Now this MC, this point M is at a distance of 2r from P. So this is 2r, so obviously Cp is r, and we have to find out the magnetic field due to this arc at point C, in fact at point P. So to find out that magnetic field, let us draw two diagrams. First of all, let us see that let us assume an element which is of some length dl, and let us join this element from P also, like that. So you can see that this angle, if this angle is theta, and then this angle will be theta and this will be 2 theta, because this is r and this is r, so by sine law these two sides are same and therefore the opposite angles would be same, and 2 theta will be the exterior angle of this triangle, so it would be the sum of these two angles. Okay, now we see that the r vector, let us draw the r vector first of all. Now the r vector will be like that. This is the r vector, this one, and this angle between this r vector and this dl vector will be equal to 90 minus theta, because this angle is 90 and this angle is theta, so it would be 90 minus theta. So let us now write down the magnetic field at point P. Now we also know that the current is flowing like that in anticlockwise sense, so the magnetic field at point P will be in outside the plane. So we have to add up all the magnetic fields, because all of the magnetic fields due to each small dl part will be in the same direction, and hence we can add up them. So dB due to this small wire will be equal to mu naught I dl, and dl will be equal to, you can write down dl as r into d theta. Okay, this small angle is d theta, or we can just say that this side, let us write it down as r. So this dl, this r will be calculated by sine law. So r upon this angle is 180 minus 2 theta. So sine 180 minus 2 theta will be equal to capital R upon this angle. This angle, in fact, capital R upon this angle, theta. So it would be theta. So R is equal to R sine 2 theta upon sine theta. So R will be equal to 2R cos theta. Okay, so we have written it as 2 sine theta cos theta. Okay, so this is the R, and what we can say that dl, small dl, will be equal to R, dl will be equal to capital R into d of 2 theta. Okay, so this angle is 2 theta, so it will be d of 2 theta. So dl will be equal to 2r d theta. Okay, now we should what we should do, we should write down the value of dB. dB would be mu naught I dl sine 90 minus theta divided by, now you can also take this angle if you are assuming that this angle is between dl vector and r vector, so you can also take this angle. So this angle would be 90 plus theta, so let us take 90 plus theta upon 4 pi r square. Now r is 2r cos theta, so it would be 4r square cos square theta. So dB will be equal to mu naught I by 16 pi r square, and dl is 2r d theta, and this is cos theta, so it would be sec theta. So dB will be equal to mu naught I by 8 pi r and sec theta d theta. The limit of this angle theta will be, you can see that obviously the variable is theta, and at this point if we find out the value of theta, so the limit of 2 theta will be from pi by 2 to minus pi by 2 to pi by 2. This is the limit of 2 theta. So limit of theta will be equal to minus pi by 4 to plus pi by 4. Okay, so this is dB, and now B will be equal to mu naught I by 8 pi r, and the integration of sec theta is ln sec theta plus tan theta in the mod, and the limit will be from minus pi by 4 to plus pi by 4. So B will be equal to mu naught I by 8 pi r ln. Now sec pi by 4 is root 2 and tan pi by 4 is 1, so it would be root 2 plus 1, and sec minus pi by 4 is again root 2 and tan minus pi by 4 is minus 1, so it would be ln root 2 minus 1. So B will be equal to mu naught I by 8 pi r ln root 2 plus 1 upon root 2 minus 1. So if we can also simplify this term, and we can also write it down by rationalizing it, so this can be assumed as the final answer. Now we move on the next question. In this question you can see that there is a straight current carrying wire whose one end is attached to infinity and the other end is attached to a infinitely long current carrying sheet. Now this current I is going through this sheet to infinity, and this current is equally uniformly distributed among the sheet. Now we have to find out the magnetic field at this point P, which is at a distance of d from this wire. Now we know that as this disk is spreading to infinity, so we can consider that this disk is formed up of infinitely long wires whose one end is connected at this point and the other end is at infinity. So what we can do, we can all the wires are carrying a current of I, total current I. So what we can do, we can join all these wires because they all have one terminal at this point and the other at infinity. So we can join all of these wires together to form a single wire, and hence we can form another wire starting from this point and going to infinity, and this another wire will be taking the current I to infinity. Okay, so I hope you have got the point that what I have done, that you can imagine infinitely long wires which are starting from this point and going to infinity, and as we know that infinity is same for each object, so if we join these all infinite points and if we join all these wires and collectively make a single wire and lay it down to infinity, then we can see that this will be an infinitely long wire from both the ends, and we have to find out the magnetic field at point P. And due to this infinitely long wire, the magnetic field at point P will be mu naught I by 2 pi d. This we have already discussed in the previous sections. Okay, so now we move on the next question. In this question you can see that there is a infinitely long current carrying wire, but you are watching the cross section of this wire. So you can just imagine that there is a cylindrical wire. You can see the cross section of this wire, which is the cross section of a cylinder is a disc. So you are watching the cross section of this infinitely long wire. In the same way, this infinitely long wire is taking the current inside the plane, and you are watching this cross section, and the cross section of this wire is in a form of a quarter ring. So we have to find out the magnetic field due to this wire at point O. Now we know that if the total current flowing through this cross section is I inside the plane, so the current flowing through a small length, let us suppose that this angle is theta and this angle is d theta, so this length is dl. So the current flowing through this part di will be I upon the total angle through which this cross section is extending. This total angle is pi by 2, so this is 2I by pi into this small angle is d theta. So this will be the current flowing through this small part. So now this small part will be acting as a infinitely long wire, which is creating a magnetic field at this point in this direction, like that, dB. And we know that due to an infinitely long wire, dB is mu naught I by 2 pi r, because both the angles are 90-90, so sin 90 plus sin 90 will be 2. So dB will be equal to mu naught by 2 pi r, and I will be di, so it would be 2I d theta by pi. So dB will be equal to mu naught I by pi square r into d theta. Okay, now we know that there will be two components of this magnetic field. This will be by and this will be bx. So by will be equal to integration of dB cos theta, and dB is mu naught I by pi square r cos theta d theta, and limit of theta will be from 0 to pi by 2. So it would be mu naught I by pi square r. Integration of cos theta will be sin theta, and limit will be from 0 to pi by 2. So it would be mu naught I by pi square r. This is by. And if we again integrate bx, so bx will be integration of dB sin theta. So limit is from 0 to pi by 2. So again the same result would be obtained, mu naught I by pi square r. So we can say that the net magnetic field will be under root of bx square plus by square, and as bx and by are equal, therefore the net magnetic field will be equal to root 2 mu naught I by pi square r. So this will be the final answer. Now let us move on the next question. In this question you can see that there are 6 long parallel current carrying wires which are placed at the vertices of the hexagon. This wire is taking the current outside the plane, this wire is taking the current outside the plane, this wire is taking the current outside the plane, same as this, but this is taking the current inside the plane. So we have to find out the magnetic field, net magnetic field at this point O. So this is a easy problem, and you can see that if we join the opposite vertices, so you can see that the magnetic field due to this wire, due to this one, will be in the upward direction, and the magnetic field due to E wire will be in the downward direction, like that. The magnetic field due to D wire will be like that. The magnetic field due to A will be like that. So these will be cancelled out, but the magnetic field due to C will be like that, and the magnetic field due to F will also be like that, because the current flowing in them is in opposite directions. So B due to any one of them will be mu naught I by 2 pi. This distance is also A, so A, because this is an infinitely long wire and both the angles phi 1 phi 2 are 90-90. So there will be a factor of 2 and it would be cancelled with 4. So B will be this. Okay, and the net magnetic field will be mu naught I by pi A, because it would add up like that, and this angle would be 90, so this is 60, so this will be 30, so this angle is 30. Okay, and this will be also 30. So we can also find out the components of the net magnetic field, but it is not being questioned in the problem, so we are just calculating the net magnetic field. Thank you.